Hey guys, so the last section of chapter 10 that we're going to do is this one where you're interpreting what's called the discriminant, okay? This one's pretty easy, right? You have to be able to know the quadratic formula, okay? Now the discriminant is just a little part of the quadratic formula that's on the inside of the square root, okay? So the b squared minus 4ac part. And we're really just going to use that. We're going to have to obviously commit that to memory, b squared minus 4ac. We're working with the same equation, ax squared plus bx plus c, like this form right here. And what that discriminant does is it helps us decide what type of roots we have, right? What type of answers to our solutions we're going to have. All right, so if this d is positive, if the b squared minus 4ac is positive, then you're going to have two roots or two answers. Right? If it's 0, you're going to have just one root or one answer, and if it's negative, you're not going to have any. Now, let me explain a little bit why that makes sense, because this is the quadratic formula. If we plug the d in, looks like this: x equals I gotta sneeze. Okay, negative b plus or minus the square root of this whole thing, right? The square root of b squared minus 4ac is just the d, all over 2a. Alright, so if that d is positive, then you're going to have two possible answers, because you're going to have negative b plus that square root, negative b minus that square root, and those are going to give us two answers. Alright, if d is 0, then this whole thing is just going to go away, and our one answer is just going to be negative b over 2a. Alright, and if d is negative, it's going to be a negative square root, which we can't do, so that's why you're going to have no real answers. Okay, so that's all you're going to do is you're going to calculate this discriminant and determine the nature of the roots. Okay, so for this first problem, without solving, determine the nature of the roots. So remember that we've got a, b, and c. Okay, so we've got d equals b squared, so 8 squared minus 4 times a times c. Okay, 8 squared is 64, and 4 times 3 times 7 is going to be let's see, I'm going to do my calculator. 12 times 7 gives us 84. So we have 64 minus 84 equals negative 20. So now, remember that up here, I said if d is negative, you're going to have 0 roots. So, the answer is 0 roots. Okay, and number 2, okay, we've got a is 1, because there's nothing there. Remember, b is plus 2, c is minus 3. Okay, so that's our a, b, and c. So d equals 2 squared, b squared, minus 4 times a times c. So we have 2 squared is 4. Negative 4 times 1 times negative 3 is positive 12. So d equals 16. Well, what does that tell us? Since d is positive, we're going to have two roots. And lastly, number 3, we have a, b, and c. So we have d equals b squared minus 4 times a times c. So 20 squared is 400, and 4 times 4 times 25 is also 400. So we have 400 minus 400 equals 0, which tells us we have just one root. That's pretty much it. We're going to do a couple more examples here, just with ones that we have to manipulate. So number 4, we can't do anything yet until we get everything to the left side, so we have to add that 4x over. So 4x squared plus 4x plus 1 equals 0. Now we see that we have a, b, and c. So we get to do this discriminant. B squared minus 4 times a times c. And 4 squared is 16 minus another 16 equals 0. Tells us there's one real root. In the last problem here, we have 1 for a plus 7 for b minus 2 for c. So d equals b squared minus 4 times a times c. So d equals 49 minus, we've got negative 4 times 1 is negative 4. Negative 4 times negative 2 is 8. So equals 57. Since 57 is positive, that tells us we have two roots. And that's all with the discriminant. Done with chapter 10 forever.